Hello, so welcome to our discussion on design patterns. So this one will be talking about the Poolable Manager. So this one is an implementation of the singleton. So the singleton is here. We can see that it does the check if it's the only instance in the scene. If it's not, well then it destroys itself. Okay, so with that, let's talk about the singleton. So a singleton, the Poolable Manager. So the Poolable Manager is basically it creates a bunch of clones of the same object and then adds it to a pool. So for our pool here, we call it the list of inactive objects. So then whenever we need an object, we draw from this inactive pool and of course remove the reference from here. So this isn't comparable to imagining playing a game of cards. So of course you have to get all your cards and then prepare them in a deck. Then whenever we want a specific, we want to play, we draw a card that hasn't been used yet and then of course remove that from the deck. Okay, so the use cases of this is basically optimization. If you were to instantiate, let's say, a very high poly car with, of course, a lot of details, well, then you'd notice that there'll be frame drops and lag in general during runtime. So this is because you have to load in the mesh, the textures, the normal maps, and whatever other assets that are associated with. So yeah, that can be very expensive. So instead of doing that at necessarily always at runtime whenever you're playing, why don't we do it when we're booting things up, when we're setting it up? So this is why on Poolable Manager start, this is where we do things. So on start, we first basically we clone the original object a bunch of times. For me, I want to clone it 10 times. So when we cloned it 10 times, we added it to our inactive objects pool. So then whenever that's finished, we just destroy the original object since we don't need it anymore. Now, if someone were to want to use a reference or get a poolable, well then we can do this. We can first check if the inactive objects has at least like one we could draw from. If not, if it does, then we'll just get the first one and basically remove it from the list. Then we'll set that object to true and then return it. So let's see how this is used. So let's say player, whenever my space key is pressed, I want to be able to get one. Then whenever I got one, I just want to move it to wherever my player is, and then I want to shoot it forward. So this is get the rigid body and then add a bit of force. So let's see that. So there we go, the scene is loading. We see that it created a bunch of clones of the sphere. And then we also see it here in our inactive object list. And then the original object, of course, we don't need it anymore, so it's destroyed. So now, if I press space, you can see that it shoots out a bunch of spheres. So give it like 5 seconds. That's the lifetime I gave it, and it'll deactivate itself. So whenever it deactivates, it should return itself to this pool. So let's see that. So let's go back to our Poolable Manager. So a key component of Poolable Manager is that you'll eventually run out of objects. This is intended. This is so that you don't create too many instances of the same object, and of course waste memory. Since on certain scenarios you may just need maybe a limit on the amount of objects you use. So let's see here. So whenever an object is not being used anymore, we should of course return it to the inactive pool. So then just return it there. And then of course our game object should be set as inactive as well. So let's see how this is used. For my scenario, my poolable object, it deactivates whenever the timer runs out. So this is a coroutine. So we wait for 5 seconds. After 5 seconds, the game should be deactivated, and of course it should be returned to the pool. So then this is why it looks like it's despawning. Pero the object is not destroyed, it's actually being deactivated only. So now, let's encounter a scenario where we run out of poolables. So there we go. I'm trying to access poolables, but again, we're returning null because we already ran out. So let's optimize this a bit, or let's refactor our code. Okay, so we saw that previously before it returned null, so that was causing the error. So let's create a variation of this, which should have instead of returning the object directly, we could instead do a return of the type first. So public bool, and then whenever it's, of course, the list is empty, we return false. Whenever the list has something, well, we return true. Okay, good. Now, we actually haven't returned the object yet. So to do that, we can use this. We can use a keyword of out. our reference. But for my scenario, I'll be using out. Then just give the type and as well as the name for it. So let's call it poolable. So now let's first initiate poolable as of course none. So what happens here is that whenever the inactive object is insufficient or our pool doesn't have anything, of course it returns false, and then our poolable is null. Whenever it has something, well then we'll change this instead. So our poolable will be the target variable. Ta-da! So now poolable game object that's exactly okay. So what we have here instead is first we're returning a boolean. As well as that, we're also outputting this poolable variable. So how do we use this? So let's see inside our player. So here's the player. Instead of directly calling this, we could do a boolean check first. So here, instead of doing this, let's just comment that out. Poolable that try request poolable, then out poolable object, and then what do we name it here? Poolable. Okay, so then if this is true, well then we can continue. Otherwise, if it's false, well we could do maybe a debug.log warning. No poolable available. Ta-da. So now there is also another method, which is just doing a simple null check. So let's say we return the poolable, then we want to do something with the poolable. We could actually do this instead. So the question mark is basically a check if it's null. But then there are certain scenarios where it's best to know the fail scenarios already. So for our scenario, it's in case it's the scenario where the poolable isn't available. So now let's try using the entire pool. So again, there we go. So we have our little own field safe already, and it's working quite well. So again, whenever 5 seconds is up, whenever the coroutine finishes, they add themselves back into the inactive pool. Now, there's also another optimization we can make, which is on the data types. Recall that our Poolable Manager was getting the first one. It doesn't really matter where we get, as long as we're getting one from the list. Well, we could actually convert this to either a stack or a queue. I'm going to use a stack. So this is also similar to a list, except we're only getting and adding from certain directions. It could be from the front or the back, or rather the top of the list or the bottom of this. For this one, since it's a stack, this is it adds to the top and then it gets from the top as well. Imagine a stack of papers. So there. So now we just have to change this out a bit. Instead of add, we're gonna use push. And then instead of manually doing this, where we have to get the object reference first and then remove it, we could do this instead, which should be from our inactive objects pool, basically just pop. So pop will remove it from the list and as well as output it. So that's two actions in one. So then let's see here. And then if we were to request a poolable, so this is just the same. This is just with our failsafe. So there, pop. And then for here, if we were to return it to the list, again, we need to use push instead of add. Okay, let's see that. Yeah, there it is. The inactive objects disappeared. This is because stacks are not supported in the editor view. So you just have to trust it. So the only variables that are the only data types or containers that are supported in the view are arrays and lists. Dictionaries are not. Stacks and queues are not. Anyways, let's see. Again, we have a null reference, so I believe. Okay, so small error on my part. So it's just I accidentally assigned it to a new value instead of using the output. Okay, so this is the correct way of doing it. Okay, we activated enough, and then there. So it functions similar to again the list, except it's more optimized. Since a list is dynamic, so the size changes, while the stack also may change, but then it's more optimized through some magic. Okay, so to summarize, so basically we have our Poolable Manager, which controls which clones a bunch of poolable objects at runtime. Then it adds it to its own pool. Then whenever someone needs a poolable, they'll request for it. If it's available, well then they'll use that. So the game object is set to true, and then they're able to do whatever they want with it. So in this scenario, they were able to use that poolable, move it around, and then shoot it. Now, whenever a poolable is done being used, let's say it exceeded its lifespan or its time limit, or it hit an obstacle, well then of course it should deactivate itself, then of course return it to the poolable so that the cycle continues. So our pool list is being actively drawn from, and as well as refreshed whenever, of course, the poolable object is done being used. So that's pretty much it.